students, welcome back. Heat is a term which we are very familiar with in our day-to-day lives. Sometimes we say that, oh, this tea is really hot. During summer, when there is an electricity failure, we all feel uncomfortable due to the atmospheric heat, right? Nowadays, it is very hard to live without a fan or air conditioner as they give us good relief when the temperature is hot. On the other hand, we regularly come across colder objects like ice. How do we decide whether an object is hot or cold? An easy answer is that we can touch and decide. But is it a reliable method all the time? Let's find it out through an experiment. Take three containers A, B and C. To A, pour some hot water. To B, some cold water. And to C, a mix of hot and cold water. Now dip your right hand in hot water, left hand in cold water. After that, dip both of your hands simultaneously in container C. We know that container C has a mix of hot and cold water, but your hands will tell you something else. Your right hand will have a feeling that the water is cold, as you previously dipped your right hand in hot water. Your left hand will sense that the water is hot as you previously dipped your left hand in cold water. From this experiment, we can conclude that we cannot always rely on touch to decide whether an object is hot or cold. Not only that, touching a hot object can be dangerous. It can burn your hands. Now, a reliable method to measure the heat of an object is its temperature. We can measure the temperature by using a thermometer. Now, let's learn more about thermometer. You all might have noticed that when we get fever, it is measured by using thermometer. The thermometer which is used to measure the body temperature is called a clinical thermometer. A clinical thermometer has a long, narrow, uniform glass tube and a bulb at the end. This bulb at the end has mercury inside it. Mercury is the only metal which is liquid at room temperature. Mercury is used in thermometers because it expands uniformly when heated. It is a good conductor of heat. That means it can pass heat easily, and it does not stick to the walls of the glass tube. We can find a scale in the thermometer indicated by degree Celsius. It reads temperature from 35 to 42 degrees Celsius. We can see another scale in thermometer which reads temperature in Fahrenheit. Here it is written in Fahrenheit and this is degrees Celsius. Fahrenheit scale ranges from 94 to 108. There are some points which we should remember while using a clinical thermometer. Before using the thermometer, we should wash it with some antiseptic lotion. This will help to prevent the spread of infection from one person to another. Before using the thermometer, we should give it a few jerks so that the mercury inside it falls below 35 degrees Celsius. Otherwise, we will not get an accurate reading. After this, place the bulb of the thermometer under your tongue or underarm and keep it for 1 minute. After 1 minute, take it out and mark the readings. The normal human body temperature is 98.6 degree Fahrenheit or 37 degree Celsius. Any readings above this is an indicator of fever. You should keep in your mind that the normal body temperature of every person should not be 37 degrees Celsius accurately. It could be slightly higher or lower. The normal body temperature is considered as the average body temperature of many healthy people. The human's body temperature will not fall below 35 degrees Celsius or above 42 degrees Celsius. That is the reason the thermometer has a range between 35 degrees Celsius to 42 degrees Celsius. The clinical thermometer has a kink near the bulb. This is the kink. The kink will help to prevent the mercury from falling down by its own. Otherwise, the mercury will fall as soon as we take it out of our mouth and we cannot read the temperature properly. We should not use this clinical thermometer to measure the temperature of any other hot objects as it may break. We have just now learned that we cannot use a clinical thermometer to measure the temperature of any other hot objects. This purpose is saved by the laboratory thermometer. The range of laboratory thermometer is between minus 10 degrees Celsius and 110 degrees Celsius. Here you can see this is 0 degrees Celsius and this is minus 10 degrees Celsius. This is 110 degrees Celsius. And the range of laboratory thermometer is between minus 10 degrees Celsius to 110 degrees Celsius. Let's see how we can measure the temperature with the help of a laboratory thermometer. Take a beaker of hot water and dip the bulb of the thermometer inside it. It should not touch the bottom of the beaker. Now read the temperature without taking out the thermometer. This is because if we take it out, the mercury inside it will fall by its own as it has no kink near the bulb like the one in the clinical thermometer. This is one reason we cannot use laboratory thermometer to measure the temperature of human body. Now here you can see the temperature of water here is 60 degrees Celsius. Nowadays, we use digital thermometers instead of mercury thermometers. Mercury is toxic substance and it is difficult to dispose it of if the thermometer breaks. Your mom might have restricted you from touching a pan or any other utensil on the gas stove as it is hot. First, when you place the utensil on the gas stove, is it hot? No, it's not. The heat flows from the flame to the utensil and makes it hot. After removing the utensil from the gas stove, it starts to cool down. Do you know how it cools down? It cools down because the heat from the utensil flows to the surrounding air as the surrounding air is cooler than the utensil. The heat always flows from a hotter object to a colder object. Let's do an experiment to see how the heat flows. Take a rod of any metal and put some pieces of wax on it at an equal distance. Place one end of the rod between two bricks so that it stands horizontally. Now heat the other end of the metal rod. We can observe wax pieces falling down. The pieces near to the heat source will fall down first. Then the heat slowly spreads to the other end. From this we can conclude that heat transfers from hotter end to the colder end. The process by which heat is transferred from a hotter object to a colder object is known as conduction. In solids, the heat is transferred by conduction. But all objects will not transfer heat in the same manner. You might have observed that the iron pan has a wooden handle. This is because wood will not transfer heat easily and we can hold the pan with the help of this wooden handle even though the pan is hot. There are some objects which will allow the heat to pass through them easily. They are called conductors. They are good conductors of heat. Examples of conductors are metals. But there are some objects which will not allow the heat to pass through it. They are called insulators. Examples of insulators are plastics and wood. We learned that in solids, heat passes through conduction. Now let's see how heat gets transferred in liquids. Take a beaker and fill half with water. Place it on a tripod and place a lighted candle or Bunsen burner below it. Wait till the water in the flask stands still. Place a crystal of potassium permanganate at the bottom of the flask gently by using a straw. When the water is heated, the water near the flame gets hot, this area. This will get hot first. We can clearly see this with the help of the color of potassium permanganate. Then the cold water from the sides moves down and gets heated and moves up. The liquid in the hot area is less dense than the liquid in cold area. This area the liquid is less dense and here the liquid is more denser. As the hot liquid is less dense, it rises. Again the water from the sides moves down and gets heated up and rises. This phenomenon continues till the whole water gets heated. This mode of transfer is called convection. Now let's see the heat transfer in gases. Light a candle and place one hand above it and one hand on the side. Your hand won't be equally hot. The hand above the candle feels hotter than the other. This is because the air above the candle becomes hot first and it rises up as it is less dense than the cold air above. Now the air from sides moves down and becomes hot and then rises. This is the reason the hand above the candle feels hotter than the other. From this we can conclude that the transfer of heat in air happens in the same manner as in liquids. The mode of heat transfer in gases is also convection. Convection is possible only in liquids and gases because their particles can be easily dispersed. But in solids, the particles are tightly packed and hence the mode of heat transfer in solids is conduction. Let's see what happens in coastal areas during the daytime. During the day, due to the sunlight, the land and water in the oceans get heated up. But soil gets heated up faster than water. When the soil gets heated up, it transfers the heat to the air just above it. As a result, the air just above gets heated and as it less dense, it rises up by convection. As the air moves up, there forms a low pressure area above the land. But the air above the ocean is not yet hot and there is a high pressure area above the ocean. Hence, the air from high pressure area moves to the low pressure area. That means air moves from ocean to land. This is called sea breeze. But during the night, exactly the reverse action takes place. At night, both the ocean and land cool down, but the soil cools down faster than water. As the air above the ocean is still hot, it rises up and forms a low pressure area above the ocean. But as the air above land is cold, there is a high pressure area above it. Then the air from high pressure area moves to the low pressure area. That means air moves from land to ocean. This is called land breeze. Have you ever thought how the heat from the sun reaches earth? Conduction is not possible as space is not a solid medium. Convection is not possible as well as there is no liquid and air in space. Heat from sun reaches us through another process called radiation. Radiation can happen if there is a medium or not. You might be aware about the room heaters. Room heaters can be placed in any corner of the room, but it transfers heat to the entire room. An iron pan cools down once it is out from the flame as it radiates the heat to the surroundings. Radiation is the fastest method of heat transfer. When heat falls on an object, a part of it is reflected, a part is absorbed, and a part may be transmitted. We are advised to use an umbrella when we go out in the sun because an umbrella protects us from the heat of the sun by partially reflecting the heat radiation. It reflects the heat radiation from the sun. You might have noticed that the umbrella gets hot while we go out in the sun. This is because an umbrella absorbs a part of heat. Do you know why we are advised to wear dark colored clothes in winter and light colored clothes in summer? Let's find out an answer through an experiment. Take two tin cans and paint one with black and the other with white paints. Pour an equal amount of water on both and keep them in the sun for about an hour. After 1 hour, touch both the pans. We can feel that the black colored tin is hotter than the white colored one. This is because dark surfaces absorb more heat and light colored surfaces reflect most of the heat falling on them. This is the reason why we feel comfortable wearing dark colored clothes in winter as they absorb heat. In summer, we should wear light colored clothes as they will reflect most of the heat falling on them and thereby save us from hot climate. In winter, we prefer to wear woolen clothes. Wool is a poor conductor of heat. Not only that, there are gaps between the woolen threads. These gaps trap air inside and again air is a poor conductor. Air prevents the flow of heat from escaping out from our body to the outside environment and thereby keep us warm. That's it about the chapter heat. If you like this video, please share it with your friends. If you have any queries, put it in the comment box. Thank you.